Welcome to day 2 of transformations. Today we're talking about reflections. Whenever I think of reflections, I think of this art project I did when I was little, and where you would paint on one side of the paper and then fold it over, and you would see the mirror image on the other side. So I thought I'd start with that. So let's do that. I didn't have any paint, so I'm going to use some glue. And I'm just going to make sort of a cinnamon roll type swirl here. Great. And we're going to fold it over like a reflection. And what you see on the other side is the mirror image of that. These are congruent. So what do we have? We have an isometry, because this transformation, we have congruent shapes. They're reversed in orientation, kind of like when you look in a mirror. But they're nice and evenly spaced from the center line, and that's how I think of reflections. So when we go to your notes for the day, if you could take out your note sheet, the first thing that we're going to do is figure out what our fold line is, and then we're going to recreate that little art project. So let's just quick go through these and find where our fold lines are. So number 1 says the x-axis. That's our fold line. Number 2 is the y-axis. Number 3 is the line x equals -1. So if you just think of all the points on the graph that have an x value of -1, that would be all of these points back here. This is the line x equals -1. Y equals 1 would be all the points that are up at y equals 1. Winds up being a horizontal line. Number 5, this is more like a y equals mx plus b sort of line with a slope of -1. Or you can think of the y value being opposite the x. So if x is 3, y is -3. So it's just going to be this diagonal, perfect 45-degree angle. There it is. And the last one, y equals x. Again, mx plus b, you'd have a slope of up 1/1. Or you could think of 1, 1, 2, 2, 3, 3, where the y equals the x. Once you have your fold lines ready to go, then we're going to work on our reflection. So number 1, if we're reflecting this triangle, can you imagine that it's going to wind up in the 4th quadrant? So point A, let's go point by point. Point A, if it flipped over, would now be down at -2 for A prime. C was up at 1, so now it's going to be down at -1. And B was up here at 4, so if it flips over the line, down at -4. When you connect your dots, that'll transfer the entire thing to make our image, and they should be congruent. You want to be a little careful on the second one because you want to keep track of which point is which. The D folds to D prime 2 units away from the fold line. A is the one that's further away. So A prime winds up on the right side. So just keeping track of which points pair together. Alright, let's find the image of this one. So what would happen if you had paint on both sides of your fold line? How would that work out? So the point A right here would fold across this line. So it's 2 units away from the line. So A prime is going to be 2 units on the other side of the line, which is actually only out at x equals 1. Same thing for B. B was 2 away from the fold line, the line of reflection. Now what happens to C? When you fold it, C shows up on the other side of the line, only that's, in this case, the left side of the line. So this one might feel a little bit awkward because the image and the pre-image overlap. But you should expect that if your line of reflection intersects your shape. Number 4, we've got that happening again. So anything above the line reflects below, anything below reflects above. So maybe I'll just start with B and C. A was only 1 unit above the line, so only 1 unit below. Same for D. You'll be able to tell if you messed up because you won't have a congruent polygon. But I think that looks okay. Looks like it got folded on the line y equals 1. For these slanted lines, here's what I suggest. I suggest turning your paper so that maybe your line is vertical instead, and then just thinking of going horizontally across that line. So see how we're going to sort of have to go at a diagonal. So A is 1 diagonal away, so A prime will be 1 diagonal away on the other side. B, you have to go straight to the line, so 1, 2 diagonals away, 1, 2 diagonals away. And what happens if you have a point that's right on the line of reflection, like D? It's like having paint right in the crack of your paper. It doesn't go anywhere. So D prime and C prime actually stay put. You connect your image, should have a nice congruent reflected piece. So on the last one, again, I would suggest maybe turning your paper to visualize it better. So we're going to try to intersect straight across, perpendicular. So C actually goes 1.5 boxes to the line, so we're going to go 1/2 and a 1, 1.5 to the other side. A is 1 away, 1 diagonal away. And B, 1, 2, 3. Check for congruence there. Looks okay. Lovely. All right. Top 3 interesting facts about reflections. If you could turn your little note sheet over, we're going to write these down. A reflected image is congruent to the pre-image. Reflections are isometries. An isometry. A translation requires a direction and a distance, like a vector, right? A slide vector. A reflection, we don't need a direction and a distance, we just need a fold line. If you would write the word line right there. And I brought in the birds for this last one because it's a little bit confusing. But if you think of reflecting these birds, it looks like their line of reflection is sort of diagonal today. Oh, that was terrible. Something like that. So let's think of just like a wing point. Let's say wingy point P here reflects to wingy point P prime over here. So what this last little property thing is talking about is the segment that joins P to P prime. And I've kind of said both of these things, but these should be equidistant. This should really be the midpoint, right? And on top of that, when you turn your head, you always want that to be nice and perpendicular, a nice 90-degree angle. So the last one is the fact that it's perpendicular at the midpoint. The line of reflection is the, well, you write perpendicular bisector. All right, let's put it into action. We've got another example here. If you're super lazy, like me, we're trying to maximize efficiency here. Let's say you work at Herberger's, that's here on the map, and you want to go to Orange Julius after work. So you have to go to your car. Now normally I would park right here because it's a nice short distance. Employees have to park behind this line to save all the good spots for the customers. So I would park right here. But if I wanted to also get an Orange Julius, that's kind of a walk. So maybe I'd plan it strategically and park my car more here or more here. So the idea is, where should I park my car so I get the least exercise possible when I make that little walk? I wouldn't want to park over here. That's a long walk. So this problem is actually probably easier if Orange Julius was across the street. So let's imagine, see the reflection here? If Orange Julius were across the street, then shortest distance would be a straight line. So I would probably park about here. But if you think about it, this walk to Orange Julius and this walk to Orange Julius should be the same. And so even if Orange Julius is on this side of the street, I would want to park right there so that my walk would be the shortest as possible. Now that's a theorem, but I think it makes sense. So you're just going to reflect, imagine it across the street, and that'll find you that perfect parking spot. Oops. Last thing, I want you to get proficient with some ruler work here. So let's try this on my paper again. So again on here. So we're going to try to see what would that look like if I folded my paper and folded that onto the other side, a reflection. We're going to use rulers. So what I want you to do is maybe use a note card, because we need to make that perpendicular when we fold, right? So this is a nice 90-degree angle. And so maybe that'll just help you sort of visualize the right angle here. We want to get that perpendicular. Maybe you want to do all of your perpendiculars first. So each of these needs to go perpendicular across the line. I'm just going to do the vertex points. Alright, so we kind of have a plan. I'm picturing the triangle sort of being like that. But then we'd want to make sure it was a perpendicular bisector, so that's where the measuring comes in. So it looks like this first point is maybe 4.1 centimeters from the reflection line, so I'd want to go 4.1 for my image point. So you're just going to do that each time, maybe 0.6 or 0.7, pretty close to the line. And looks like exactly 2. And so that's a nice way to get a pretty accurate reflection. Making sure you're going perpendicular and that you have those equal distances in there. Alright, pages 3 and 4 of your fantastic packet. Thank you.